Welcome to the Deep Dive. We're here to take complex information and, well, make it really understandable, maybe even a little surprising along the way.
It's great to be here.
Today, we're pulling back the curtain on architecture, specifically the schematic design phase.
Yeah.
We've got some interesting stuff to look at: client requirements, site analysis, those early ideas.
Right, those initial sparks.
Exactly. It's that moment where needs, abstract needs, start to become something, well, tangible, a real concept.
It's where the building starts to take shape, conceptually at least.
So if you've ever wondered how buildings actually come to be, this is definitely for you.
Hmm.
And hey, if you enjoy this kind of inside look, please do hit that subscribe button. You won't want to miss where we go next.
Definitely subscribe.
Now, we have our expert with us, ready to guide us through this.
Happy to help unpack it. Schematic design is fundamentally that first big leap from ideas on paper or maybe just in conversation into an actual architectural concept.
So it's moving from the what if to the, okay, maybe like this.
Precisely. It's defining the what will be built. That's the core goal. Setting it apart from the later phases like design development, which get more into the how it's built materials, systems, the real nuts and bolts.
Okay, so schematic design. Let's really get into that. It sounds quite official. What's the heart of it?
At its heart, it's about turning all that pre-design work the client's needs, their vision, the budget constraints, site info, into a coherent architectural idea, a physical concept.
So it's not just the architect off in a corner sketching. It sounds like there's a lot more back and forth.
Oh, absolutely. It's highly collaborative. Crucially, the architect and the client really need to reach an agreement on the, let's call it the architectural expression.
The overall feel and form.
Exactly. And that expression has to synthesize a whole bunch of things: the character of the site itself, the landscape, the neighbors, zoning rules. Then there's the functional program.
Which you mentioned comes from pre-design.
Yes, the detailed list of spaces and needs. Plus, the client's desired image, what they want the building to say. And, of course, the architect's own design sensibilities and approach. It's a blend.
That sounds like juggling quite a few things. How vital is that pre-design work, that functional program you keep mentioning?
It's fundamental. You really can't overstate it. That functional program acts as the roadmap for the entire design process.
A roadmap. I like that.
Yeah, it guides everything. Trying to jump into schematic design without a solid program from pre-design, that's a recipe for problems later on. Scope creep, budget issues, the final design maybe not quite hitting the mark.
So skipping that step is asking for trouble. Okay, roadmap in hand, what does the architect actually do during schematic design?
They essentially start testing that program against reality, exploring different ways to arrange the spaces, planning relationships, adjacencies, and exploring the massing the building's overall shape, its volume, how it sits on the land.
And this is all while keeping an eye on the budget.
Constantly. The goal is finding the best possible synthesis, the sweet spot that balances the client's needs, the site's potential and limitations, and the financial reality.
Now, you mentioned different ways to develop these designs, something called an integrated design team, or IDT. What's that about?
Right, the IDT approach. It's a very collaborative model. It brings together a whole team of experts right from the beginning.
Not just the architect and client.
No, it includes engineers, specialists, maybe sustainability consultants, and importantly, the client is an active participant throughout. Sometimes even a facilitator helps keep everyone focused on the goals.
And why take this approach? What's the benefit?
Sustainability is a big driver. The IDT can look at the whole life cycle impact of decisions. Think about trade-offs, for example. Maybe investing in high-performance windows costs more upfront. But the IDT, working together, might realize that allows for smaller, less expensive HVAC equipment and, lower energy bills long-term.
So it connects decisions that might seem separate otherwise.
Exactly. It combats that siloed thinking. Early collaboration just unlocks better, often more efficient solutions.
That ripple effect is fascinating. The material also mentions documenting decisions and a move towards more front-end loaded work. What does that mean for this phase?
Front-loading. Yeah, that reflects how technology has changed things. We can do more detailed thinking earlier now. Tools like BIM building information modeling are key.
BIM. That's like a digital twin of the building.
Essentially, yes. A detailed 3D model you build digitally right from the schematic stage. It allows for a much more holistic view, understanding how systems interact very early on.
Like testing performance virtually.
Right. You could even model energy performance at this stage. but it requires a significant amount of information and effort up front during schematic design. So project schedules, how architects bill for their time, that needs to adjust to reflect this earlier intensity.
So more work early potentially means fewer surprises later.
That's the idea. A better understood design from the get-go.
Okay, thinking about the design and the program, is it always the program driving the design? Or can the design influence the program back?
That's a great question. Mostly the program is the driver, but as the design takes shape, you might uncover things. An insight, maybe a more efficient way to lay things out, or even a conflict in the original program.
Ah, so the design process itself can reveal things.
Exactly. So it's vital to keep testing those pre-design assumptions during schematic design. It's the perfect time for course corrections before you get too far down the road into detailed design.
Makes sense. Avoid major U-turns later.
Oh.
Now, who else joins the team at this stage? You mentioned engineers with the IDT.
Right. This is typically when the core subconsultants come on board. Structural engineers, mechanical, electrical, M&E, we often call them.
Mhm.
Depending on the project, maybe civil engineers for site work, landscape architects, acoustics experts, traffic consultants, even elevator specialists if it's a tall building.
And what are they doing at this early stage?
They're getting familiar with the site, looking into potential materials and systems for their discipline, gathering detailed site info like utility locations, setting up the technical basis for their work, and reviewing assumptions.
So the structural engineer's already thinking about how to hold the building up, even based on early massing.
Exactly. They might see an early sketch and say, whoa, that long overhang, that's going to be tricky, prompting an early rethink. The text also rightly mentions intern architects. This is a great phase for them to contribute conceptually.
A real team effort forming. Let's talk more about the architect-client relationship here. The ideal is co-participation. What does that look like, practically?
Ideally, it's a true partnership. Shared goals, mutual respect. RAIC Document 6, a standard Canadian contract, actually talks about this spirit: respect, support, openness, good faith. It recognizes design is a journey, not always a straight line.
So communication is key.
Absolutely paramount. It's an ongoing dialogue. The architect presents ideas, explains the rationale, links it back to the program, and both sides need to stay aligned on the fundamental goals.
How does the architect manage that communication?
They really orchestrate it, keeping design issues and, critically, budget implications open for discussion. And documentation is vital. Meeting minutes are crucial recording decisions, circulating them for review.
Makes sense. Everyone on the same page.
For really key meetings, sometimes having someone just dedicated to taking notes is smart. Frees up the main architect to focus purely on the design discussion. Junior staff or interns can be great for this.
Now, sign-offs. The text mentions clients might sometimes hesitate to formally sign off at milestones. Why is that, and how do you handle it?
Yeah, it can happen. A client might just not feel 100% certain yet. Or they worry signing off locks them in, meaning any later change costs extra. Sometimes it's just linked to invoicing, maybe a disconnect on how much work a sign-off represents.
So how do you build that confidence?
There's no single trick, but clear, continuous communication is key. Walk them through the design's evolution. Explain the why behind decisions. Be transparent about how changes after sign-off could impact schedule and fees.
Managing expectations.
Exactly. Sometimes a simple visualization, like a quick virtual walkthrough of a space plan, can make all the difference in giving them the confidence to approve it.
And the budget. How often is that coming up?
It needs to be a regular touch point throughout schematic design, checking that the evolving design still fits the budget. But also remembering the client can choose to adjust the budget if priorities shift or new possibilities emerge.
What about those projects where the architect isn't dealing directly with the end users? Like a developer building condos or maybe an office building.
In those cases, the client, the developer, say, acts as the representative for those users. The architect might need to ask the client to get formal confirmation from stakeholders on key decisions.
So the architect relies on the client for that feedback loop.
Yes, and transparency is still crucial. The architect needs to be copied on relevant communications, say between the client and a contractor, if it affects design development. Open lines everywhere.
And the contract between architect and client should spell out responsibilities for this phase.
Definitely. It should be clear the client provides the pre-design info and that the architect needs that formal written approval of the schematic design before moving to the next phase, design development.
clear boundaries.
It minimizes misunderstandings, and the text flags the risk of fast-track projects where construction starts before design is totally finished. That needs very careful management and discussion about potential rework costs.
Let's circle back to that crucial pre-design information. What exactly does the client need to bring to the table?
Okay, key client responsibilities. First, that detailed functional program, what spaces are needed, how they relate, any special equipment, flexibility needs. Second, site requirements they know about. Third, a clear budget. Fourth, sustainability goals. Fifth, the desired schedule.
That's the program side. What about the site itself?
Right. They also need to provide site documentation, things like legal surveys, topographical surveys showing contours, zoning information, reports on soil conditions, geotechnical reports.
Subsurface stuff.
Yeah, and if it's a renovation, assessments of the existing building, maybe hazardous materials reports, any other professional reports relevant to the site or existing structure, it's quite a list.
It really is. What if the client just doesn't have all that? Can the architect help?
They certainly can. The architect can act as an advisor, help procure that missing info. But it's important to remember that's extra work and carries extra liability for the architect.
So it should be reflected in their fees.
Correct. Or the architect might advise the client to hire specialists directly, like for a detailed hazardous materials survey, as the architect's insurance might not cover that specific expertise.
Okay.
But the key is understanding that unknowns carry risk forward. If you start schematic design without knowing the soil conditions, that's a risk you're carrying into later stages.
And that risk.
Mm.
The text mentions clients sometimes wanting to transfer risk to the architect.
It's a common desire, maybe wanting a single point of responsibility for everything. If a consultant makes an error, the client might prefer the consultant holds all the liability.
But the architect's view.
The architect should generally reinforce that the owner, as the ultimate beneficiary of the building, ultimately holds the inherent risks of ownership. It's their asset.
A fair point. The text also calls design a learning process. How does that affect schematic design?
It acknowledges that things evolve, new ideas pop up, assumptions get challenged. Sometimes the client's own vision might become a bit fuzzy as they learn more.
So clarity can waver.
It can. And if the project objectives become unclear, sometimes the best thing is to pause schematic design. Take a breath. Reestablish that shared understanding.
And if the architect helps clarify the program or chase missing info during that pause.
That time should definitely be considered an additional service and billed for accordingly.
Got it. Okay, let's shift to the technical side. What specific technical and regulatory things are confirmed during schematic design?
The architect starts looking at appropriate construction materials and methods. They consult with the engineers on systems. They do an initial check for compliance with building codes, safety codes, zoning rules, any urban design guidelines.
Just an initial check on codes at this stage.
Generally, yes. An overview to make sure the concept is viable. The detailed code analysis usually happens later in design development.
Right, then there's space, circulation, and massing studies. This sounds like where the drawings really start happening.
Absolutely. This is where the architect translates the program bubbles into actual drafted plans. They study sizes, relationships, adjacencies, how things fit together.
The flow of the building.
Exactly. Both pedestrian flow inside and vehicular flow outside and around the site. And this is where input from engineers on space needed for ducts, pipes, electrical rooms, elevators, all that becomes critical.
So the engineers feed into the space planning.
Definitely. And for larger projects, getting client feedback, those sign-offs on these developing conceptual plans, is good practice. Then, building on the plans, comes the 3D form, the massing.
Shaping the building itself.
Using sketches, physical models, digital models, exploring how it looks, how it relates to its surroundings, how sun and shade work on it, wind patterns, drainage. It's an iterative process. You might try placing rooms, then realize it affects circulation badly, so you rethink the layout.
You mentioned the integrated design process, IDP, earlier. How does that specifically impact these studies?
IDP reinforces that everything's connected. A window choice affects HVAC, which affects electrical load. So IDP brings all the engineers' civil, structural, mechanical, electrical into the conversation during schematic design.
Early collaboration again.
Critically important. The architect coordinates this team. Early engineering input can prevent costly decisions later. Maybe the structural engineer sees a massing idea and flags a huge cost implication for a long span early on.
Saving potential headaches.
And promoting integrated solutions where systems work together efficiently. IDP also relies heavily on smooth data sharing. BIM is perfect for this, providing that common platform, ensuring everyone's working from the same model, same visual language right from this early stage.
It sounds like a much more holistic approach overall.
It really is, investing more upfront in that collaborative design effort for a better, more coherent outcome.
What if there isn't just one obvious design direction?
Yeah.
Does the architect present alternatives?
Yes, sometimes the program allows for different conceptual paths.
Hmm.
The architect might develop a few distinct options, diagrammatic studies, really, focusing on circulation, planning, volume, not detailed architecture yet.
Just exploring the main possibilities.
Right. Some clients like seeing options, but it's crucial to agree beforehand how many options will be explored, as developing multiple distinct concepts is extra work and should be reflected in the fees.
So you don't end up designing 3 buildings for the price of one.
Pretty much, you need to balance exploring possibilities with the defined scope of basic services. Eventually, one path is chosen with the client for further development.
And how are those alternatives evaluated?
Objectively, looking at pros and cons. How well does each meet the program? The budget? How are the functional relationships? Sustainability goals. What are the merits of the proposed systems? Building efficiency, like net to gross area ratios. And importantly, preliminary cost considerations.
Even if it's not a detailed estimate yet.
Right. You need a sense of the cost implications. Then, once a direction is chosen, you get that formal client sign-off before moving forward.
Which brings us back to cost. How is the building cost analysis handled at this stage?
The architect, often with a cost consultant, prepares a preliminary estimate. It's usually based on cost per square foot or per cubic meter, using regional data for similar building types.
A rough order of magnitude.
Exactly. But it's a critical reality check. Does the client's wish list fit the budget? This phase validates or challenges those initial pre-designed budget assumptions.
And if there's a mismatch?
Then you have a serious conversation. Adjust the scope, change the quality level, increase the budget, or does the project need rethinking entirely?
Tough conversation sometimes.
They can be. With IDP, the team is ideally budget conscious from day one, trying to design to the budget, avoiding that kind of major clash later. But if a fundamental incompatibility persists, you have to address it head on.
Okay, so you've got a chosen concept that seems to fit the budget. What's the final output? The documentation and presentation.
Right, you package it all up. The goal is to clearly show the functional relationships, the scale, the overall character of the design that came out of the program, schedule, and budget discussions.
What does that typically include?
Usually a site plan, floor plans showing functional areas, key building sections showing height and structure concepts, outline elevations showing the massing, and look, maybe some illustrative sketches or simple 3D views, conceptual, not photorealistic, and often massing models.
Visuals to explain the concept.
Yes, and usually accompanied by a schematic design report. This report details the design approach, how it meets the goals, summarizes key decisions, lists sustainable features, gives that preliminary cost estimate with caveats, summarizes code and regulation status.
And a comprehensive summary.
It's a preliminary schedule, descriptions of the main building systems, area calculations, site data, maybe preliminary material ideas. It's a full package.
And the final step.
Reviewing all of this thoroughly with the client and getting their formal written approval. That's the green light to move into design development. The standard contracts, like RAIC Document 6, detail these services and management aspects too.
Wow. Okay. That is a lot that happens in schematic design. It really is that crucial translation point, isn't it? Taking all those needs and ideas and forging them into the first concrete, well, conceptual form of the building.
It truly sets the stage for everything that follows. Get it right here, and you've got a solid foundation.
So for everyone listening, hopefully this gives you a new appreciation for just how much thought and collaboration goes into even the earliest stages of shaping the buildings around us. It's
Definitely complex.
definitely complex. So many competing factors. Which leads to a final thought. Considering all those factors, client needs, site, budget, regulations, aesthetics, function, if you had to pick one, what single element do you think has the biggest impact on whether a project is ultimately successful? Something to ponder.
A tough question.
It is. And if you found this deep dive fascinating, please do subscribe to The Deep Dive. We explore all sorts of worlds like this one. Thanks for joining us.
Thanks for having me.